get started.
Okay.
Okay. Good morning, everybody. Welcome to our 2017 National Chemistry Week dress rehearsal. I'm Bob Fowler. I'm the NCW coordinator for the Cleveland section of ACS. I'd like to introduce the members of our planning committee who are with us. Mr. Vince Opasco. Applause is fine. Hold your applause to the end. How's that? Shabella Singham, way over there. She's camera shy. Miss Katie Arendt. And Helen Mayer. Did I miss anybody? Okay, I think I got everybody that's here. Want to thank John Carroll University for the use of the facilities, as always. Dr. Weiner and Dr. Nichols, who is our behind the camera person today, and also I think current chair of this wonderful department.
Yes.
He's saying something. Okay. Alrighty. Before we get started, I have several housekeeping things to take care of. And those of you watching the video, please make note of some of this stuff. Number one, for the first time this year, we have what we call partial kits. The kits are usually made up for 25 students, 5 students at 5 tables. But we're finding that some of the library attendance has been down the last several years, so we've made what we call partial kits this year. The partial kits are set up for 15 students at 3 tables. If you are using your script as you go through the program, and by the way, I recommend strongly that you go to our website and print the script. The website is actually on page 3 of the hard copy script that's in your kit. But if you'll print this, you'll get the updated version. There have been several changes to the script. They're all minor, but several of them that have been changed. I even have a couple of last minute changes to this script as well. But the partial kits, when you look at your script, it consistently refers to 25 students, 5 tables, that sort of thing. So if you have a partial kit and your label that has been prepared and will put on the kit that you get will tell you right away whether or not you have a partial kit or not. It says partial kit in red, okay, on the outside of the box. If you have a partial kit, just please understand you're going to have materials for 15 kids to be set up at 3 tables. And the libraries, Sharona, the libraries have also been informed of that. They know which ones are going to be limited in attendance to just 15 students this year. Okay, in your script, there are a couple of changes I'd like to make, and you guys don't have to take notes necessarily, but if you look at the video, on page 11, up at the top, under the setup at the demonstrators table, it talks about the presence of 26 paper towels. There are no 26 paper towels, so please scratch that. And then back on page 19, with experiment 1's right up, or right about in the middle of the page, there's a sentence, a phrase that says, materials that could be associated with fluorescent sedimentary rocks. Strike the word fluorescent there on that page. Okay, the other things that I have in the way of housekeeping, I noticed when we were going through the kits that these plastic bottles that we have, or you'll see as we go on, are going to be our version of lava lamps. Many of them are not quite so full as this one. So I'd recommend when you get home and look at your kits, remember obviously the aqueous part is at the bottom with food coloring, and this is simply corn oil, of course, on the top. Fill the thing up to about 80%, just pretty much like this one with corn oil, okay? I really strongly recommend that you read this year the background for the demonstrator in your kit. It's on page 15. This year, the theme is about the chemistry of rocks, which is a little unusual for us. There's a lot of geology involved, and we thought that since none of us are geologists, we might have a little expanded section on the background for you. So that's on page 15. and the intro to this year's program. I'll go through a little bit of that, but it starts on page 18. Please make sure you read both of those things. Also recommend that you have a long extension cord, okay? We're going to be using a UV lamp in the second experiment, and you will all have one of these to take with you. You need to be able to get around to every student in the room at one point with the UV lamp. So please have a long enough extension cord or cords so that you can get there. There are fossils. In this particular kit that we're using this morning, the fossils that we have, and you'll see how they come into play, are shark's teeth. They're part of experiment number 1. Well, for some reason, all of the little tiny bags of fossils were put in the materials with experiment 2, okay? So all the fossils are in with experiment 2. I'm not quite sure why that happened. Okay, one more thing, and we'll get going with the program, is you have in all the kits a little baggie for experiment 2, part of experiment 2, that has small labels in them. I'm not quite sure how these things got collated. Each one of the students gets 8 individual little labels, and you'll see, it says My Rock Collection on the top label. You'll see how we use these in a minute when we get to experiment 2. But I really strongly suggest that before you get to the library or wherever you're demonstrating the program, that you look in the materials for experiment 2 and see what form these are in. In this particular kit, and I know we did a lot of different things on GAC Day when we assembled the kits. In this particular kit, all of the 8 individual labels have been collated and put in a bag. Okay, so all you have to do really is lay the bags out. There's nothing more to do. In some of the kits, I feel pretty certain that the labels didn't get collated. You may have a big stack of individual things, and I suggest you go through those labels before you get to your program. In other words, do it at home. Okay? And this is what, well, we'll see that as part of experiment 2. Alrighty, to start the program, what we're going to do is we're going to explain to the students that this year the subject is the chemistry of rocks. And as I mentioned, it's a little bit unusual for all of us. Geologists typically talk about the formation of rocks using something called a rock cycle. At this point, I would call all the attention, a student's attention, to this particular item that's laying at each student's place. It's a simplified version of the rock cycle. And you explain this to the students this way. Rocks and minerals originate in the magma in the center of the earth. That's indicated by this orange blob here in the top right corner. Magma can erupt out through what we call cinder cone volcanoes, and we're all familiar with those. I understand there's a couple of them right now around the Pacific Rim. They're about ready to blow their tops. And when they erupt, the lava that's spewed out rapidly will crystallize and form what's known as igneous rocks. Igneous, I guess, comes from the Latin word for fire, so you can see the origin of that term. Igneous rocks, and we're talking now over periods of centuries, igneous rocks are worn away by erosion, acid rain, whatever, into sediment, sand, mud, that sort of thing, which then can get compressed either by virtue of layer upon layer building up or by virtue of maybe under seawater. They get compressed into what are known as sedimentary rocks. Sediment from the igneous rocks into sedimentary rocks. The sedimentary rock, well, sediment first and then the sedimentary rocks. Sedimentary rocks tend to get driven into closer and closer into the center of the Earth. And under pressure, they can actually, and heat, as they get closer to the center of the Earth, these things will actually form a more crystalline structure, these sedimentary rocks, and become what are known as metamorphic rocks. And as metamorphic rocks continue to be driven into the center of the Earth, they get back into the magma, and the cycle starts again. So we're going to explain this to the students at the beginning of the program, and then we're going to tell the students that we're going to be looking at several different kinds of experiments today. The first experiment has to do with a material called gypsum. Gypsum typically comes from evaporation of seawater, and it's associated with our sedimentary rocks. It isn't part of sedimentary rocks. These are limestone, not gypsum, the sedimentary rocks. But the gypsum is typically associated with it, and if you're ever going to find any fossils, it'll be with the sedimentary rocks and the gypsum associated with it. We're going to create our version of a piece of gypsum, which is actually plaster of Paris. We're going to put a fossil in it, just like might happen in a sedimentary rock, and that's going to be our tribute to, one of our tributes at least, to sedimentary rocks. We're then going to have an experiment which we differentiate. We show how geologists differentiate between kinds of rocks, several different kinds. Then we're going to see how minerals typically get formed as elemental minerals in rock formations, like gold or silver and that sort of thing. And then, since rocks ultimately originate from the magma at the center of the Earth and come out through volcanoes, we're going to be talking about 3 different kinds of volcanoes. And what we're going to do is we're going to imitate the action of 3 different kinds of volcanoes. We're going to imitate the action of what's called submarine volcanoes. You can imagine at the bottom of the ocean, you get magma starting to percolate up through the seabed, and it instantly encounters an infinite amount of seawater, cools and hardens. Those are called submarine volcanoes. We're going to imitate the action of submarine volcanoes, and you'll see how as we go. Then we're going to imitate the action of the second kind of volcanoes called shield volcanoes. Shield volcanoes are the kind that you find, for example, on Hawaii. And they're called shield volcanoes because the cones on these volcanoes are low and flat. And if you look at them from an airborne position, you actually see what looks like a round shield, hence the name of the shield volcanoes. And again, those are the kind where the lava slowly oozes out, and islands of Hawaii are typically formed that way. The last kind of volcano is the most action, I guess, that we're going to have this morning, and those are called cinder cone volcanoes. Those are the volcanoes that everybody thinks of when you hear of an eruption, like Mount Vesuvius back in the old days, or Mount St. Helens not too awfully long ago here in, I guess, was it Washington State? Okay, so we're going to imitate the action of 3 of those different kinds of volcanoes as part of the program today. And that will complete then the end of the program. Various members of our committee are going to demonstrate the 6 different experiments we have today. And we're going to start with Mr. Vince Opaskar, who's going to demonstrate glowing chalk. Vince, it's all yours.
Good morning. Anybody out there?
Good morning.
I'm glad to have you. I know it's a lot to ask on a Saturday morning when your work schedules are tearing you away. But we're going to do one experiment with 3 parts. It's going to come up 3 times during the program. First, we're going to start and make a mixture of the plaster of Paris and a dye, which is going to be photochemically excited, and it'll change color with UV light. Then, as we're waiting for this material to set up, we're going to move on to other areas of the program. So actually, we're going to come back to experiment number 1 2 more times. First time will be to take the molding of the piece of chalk out, And secondly, we're going to charge it up with light energy to create something which in the dark will glow. So that always excites people, watching light glow. So the first thing we're going to do in experiment 1 is to make a piece of chalk. We've done this a couple of years back, as our workforce in the audience knows. So what we want to do first is put our gloves on and our goggles on, because we're going to start handling materials right away. So if we got everybody up to speed thus far, we're going to take the materials, which would sit in front of you, and we're going to do some mixing of solid materials.
Why don't you just use one of these over here?
All right. Yeah. We're going to take the material with the bright colored dye in there. This is photoactive. And we're also going to take our vial loaded with the plaster of Paris. Okay. We're going to take the cap off and mix the two. Now there's some, it's going to be a little difficult maybe to get it out because it's been sitting around for about 2-3 weeks since we loaded these things up.
Vince, you might point out that not every kit is going to have pink dye like this one. Helen, you remember what colors we have?
We also had orange and we had blue.
Blue, orange, blue, and pink are the 3 colors that we got generously donated by the Dago Corporation this year.
Okay, it might be a little difficult to get the powder out, so to use a stick that was provided to get the two materials together. And then we're going to physically just mix the two chemicals. It's going to take a couple of minutes. And I might also point out that there is a time schedule for all of these experiments, plus or minus 100%, I think. So I can see already we're going to have a little bit of problem mixing this intimately to get it all into the color stage we want. Okay, if you feel you've got it uniformly distributed, could get a little messy. Okay, if everybody's up to speed here. Paper towels, do we have any?
I'll have to get some.
Okay.
Marcus, your label?
They're in the corner, Bob. In the corner of the table.
So I know I'm getting a little messy. If you
Maybe this is where the 26 paper towels came from that we crossed out. I might want to bring some home.
Well, many of the libraries have them available.
Yes, I'll give everybody here one.
Okay, next thing we're going to do is we're going to add the water, and there should be a W1.
Okay.
All right, now we're going to make a slurry out of this whole thing, and basically what I'm going to suggest is to fill the tube that we just emptied. All right, I'm going to measure out about 40 cc's, pour it in. This should give us a pretty good slurry when we add it to the powder.
Do we ultimately want all of this in the tube? Ultimately, all of it?
No, you ultimately want something with a consistency of ketchup.
Okay.
No.
No. You're going to add the tube, water in the tube to the cup.
Okay.
You want it open on top so you can stir it. So I'm going to add this 40 cc's. It's going to come up to the brim. We may decide to change these around. Now, this is the tough part. We want to get it to look like ketchup. Wrong color, but the consistency is what we're trying to get. The consistency of ketchup. Everybody's working hard. I can see 40 cc's of water is too much. Okay.
Maybe half a test tube.
Yeah, I'm in trouble now. Because 40 is way too much. Sorry to say. We don't have any
Well,
plastic.
we have the luxury of having extras here this morning.
Okay, good.
Let's see what happens.
Yeah, I'm just gonna get rid of that one.
$25 is good.
Yeah, she just
25,
put
yeah.
30 in hers.
We have one person.
25?
Want to mix this, Vince?
Why don't you go give it to them?
25 cc's? Let's start with that.
Oh, nice.
How much did you add, Katie?
Because
Okay, I
All
got
right,
25.
let's start with 20 cc's.
Okay,
exactly right, if I was a kid, I would do all
So I thought I gotta do it that way because I was thinking elderly for something, but that kid was in trouble.
like cooking.
okay, Vince, here's about 20 cc's.
Yeah.
Yeah, yours is still a little wet, but mine's.
Originally it said 4
Yours is
teaspoons,
looking pretty good.
which
Yeah,
was
but ketchup.
way too short.
Yep, that's good. Times.
Too bad we can't speed this process up a little bit, but it has to be mixed. How's that looking, Vince, at 20
It's looking
cc's?
much better at 20. Right, Katie?
Okay, while you're doing that, Vince, I took the liberty of taking the pieces of paper that everyone has at their place and folding it lengthwise, like that. And Vince will show you what to do with this in just a minute. You also have a film canister sitting there. You can take the top off and set the top aside for a moment.
Okay. We are going to take the gloves off to handle this piece of paper that Bob just mentioned. And you fold the piece of paper in half. And then we're going to roll it up.
This is the most of the chunk.
And it's going to look ugly, but a little practice and we'll get this thing to wrap around a finger. This is our mold. We want to get this thing as round as we can and still be able to fit it into the film canister. Okay? Take the top of the canister off. And what I found, maybe not the safest thing to do, you get a nice even circle, okay? Which will conveniently fit into the film canister. You can let it expand. Okay? Is everybody up to speed here?
Yeah, it's supposed to be taller.
Yeah, it's
I would
gonna,
recommend you mention that the folded edge should be up,
Yes,
folded edge can be
Yeah.
up.
because if not, when they pour it, they're gonna get it in the
Inside.
paper.
into the
Right.
folds.
So the
Yes.
folded edge should be at the top. Yeah, but the kids don't do that.
True. We're gonna pour our slurry ketchup in this bowl, right?
Okay, so now I flipped that around. Thank you for the suggestion there. Okay, so we got this material, and it's pretty flexible at this point, and we're going to pour about half of it into the prepared mold.
No more than half at this point. Fill the mold about halfway at this point.
Which is to say approximately 3/4 of the
Something like
height
that.
of the
Yeah,
canister.
yeah.
Pretty sure mine was
We'll just take a little.
Why don't we go?
For the
Well,
paper
yeah,
to
yeah.
absorb the water.
Hear a lot of clicking, that's good. Gonna settle this down, let it settle. When you've
No
got,
more than half full with the mold, okay?
okay, now, on the top of your table, you should find a shark's tooth or some such fossil. Okay, we're gonna plant this into the plaster of Paris.
Remember, the fossils themselves, the little bag of fossils that are part of experiment 1, for some reason, were put in the bag with the materials for experiment 2, okay? And there are many different, well, 2 or 3 different kinds of fossils that we found on Amazon, the internet, whatever. Mostly shark's teeth, but there are some snails, I guess, and various shells and so forth. The kinds of things that would have been around 3 or 4 million years ago, and even I wasn't around then.
So you say put the shark tooth in?
Yes,
Yes, on the-
we're trying to mimic the presence of fossils in sedimentary rocks, okay?
Okay, and then cover it up
With the rest?
with the rest of our plaster of
So we're
Paris.
gonna bury the fossil in the chalk, if you would.
And believe it or not, in about 30 minutes, we're gonna
Yes.
unwrap this whole thing.
And you can tell the kids that when they get home, this fluorescent chalk, they can write with it on the sidewalks, and at night they can go out and shine a flashlight on it, and it should fluoresce. And we'll see a little bit more about that in a while. But as they use their chalk up, voila, they will find a fossil. Lo and behold, inside there, our version of a sedimentary rock. How you doing, Vince?
Good. You've got it covered up at just about to the top there, tap it down, and we'll let this dry or set up, and come back in about a half hour.
Yeah, we will be back to that. Okay, shall we move on to experiment 2? Experiment 2 has to do with identifying different kinds of rocks. And what we're going to do is as we identify the rocks, the students will be preparing their own rock collection. Now, to do that, everyone has this.
Should we take our gloves off now?
No, leave your gloves on, please. And one thing that I neglected to do is that before we start, we are supposed to assign numbers to the 5 students at each table. So let's go from the left, from my left to the right. 1, 2, 3, 4, 5, okay? Remember your number. And take these little labels out of the bag and find the piece or pieces of 35 millimeter slide protectors. In some cases, there are 2 pieces of slide protectors. In some cases, there's 1. But in any event, there should be 2 rows of 4 available in each kit. Starting up at the top left, show the students how to slide this label into the first section. And of course, this one's going to be a little
Does
bit
it
too...
matter which label they're using?
No, I'm starting with the rock collection, and then we'll go to the minerals. Have them slide this in, and the way you want to finish it up is put your finger on the bottom and slide it in that way. And I would suggest, again, when you go through these labels at home, check them to make sure they aren't too wide.
Yep.
Unfortunately, these are just a little bit too wide, so cut them down a little bit at home. You have to examine them anyway. So let's put the My Rock collection at the top left, and then put the 3 that refer to minerals next. Yeah, unfortunately, these are all a little bit too big.
You know, it might just be worthwhile to preload these things.
You could preload them if you want for the kids.
Then you'll know they fit.
Yeah.
And they won't be getting their dyed gloves
You're right.
on the papers.
You're right. What there should look like, to save some time, we won't go through it right now. You guys can take those with you and complete them on your own, okay? When you're done, they should look like this. Now, I've got a complete sheet of slide protectors here, but they should look like this. I've got the My Rock collection down at the bottom, but it doesn't really matter, okay? What we're going to do is, once we've got these labels in here, and you're going to have something that looks like this when you're done, perhaps 1 sheet of 2 rows, or perhaps 2 individual rows. You should have something that looks like this when you're done. And then as we identify the various rock samples, we're going to slide them in front of the paper labels, so that when we're done, we have a complete identified rock collection. Okay, Dr. Weiner, at this point, I'm going to ask you to stand by to make the room dark, if you could. But before you turn the lights off, we're going to take the little bag of rock samples that we have. Now, I've got to tell you a couple of things about these rock samples. We of course got these on the internet, and the sizes that we got are all over the map. There are 7 different kinds of rocks in here. There's 3 minerals: malachite, pyrites, and hematite. There is pumice, there's limestone, there's marble, and there's a fluorescent rock. Now, what we're going to do is we're going to have the students take these rocks and put them into their hand, all 7 samples. Good luck trying to find the little green malachite. It's very tiny in most of these, okay? The other 6 samples could be any shape or size, okay? Now, first thing we're going to do is when the students have the rocks in their hands, let's ask them if they see anything extraordinary about the rocks, one way or the other. And the answer should be, well, not really. They're pretty much nondescript. There's one that kind of sparkles a little bit. It's brown with gold sparkles in it, but nothing really extraordinary about the rock samples. And at that point, let's kill the lights. Mark, if you would. And now the demonstrator needs to turn on the UV light while the students keep the rocks in their hands. Okay? And if you'll notice, look at the fluorescent chalk up here. Hang on. I use this extension cord at home for trimming my bushes, and I always have the same problem. Stupid thing hangs up. Okay. Can you see the fluorescent chalk up here?
Mm-hmm.
Okay, but that's not what is our interest right now.
Yeah, but they'll like to see that.
They will like to see it, and they'll see it again in just a minute. What I'd like to do is to come around and shine this on each student's hand, and let's see if there's anything, thanks Mike, let's see if there's anything in your samples that glows.
Bob, bring the,
Yes, sir.
do that so I can get a picture of it.
Okay. Can you see it?
Yep.
Okay. Anything that glows. Note the one that's glowing.
Pink.
The entire rock may glow.
Or just.
There may be one, there may be two if they're small. Just parts of the rock may glow. Because some of these, the entire rock is fluorescent. In others, there are veins of fluorescent rock. Okay? But in every event, there should be one of the rocks in your samples that glows.
Well, you got yours.
Yeah, there's a nice glowing pink one up front.
Yeah,
Okay.
there's mine.
So tell the students to pick out the one that glows. Yours is up front there.
Yeah, and that's.
Okay, and it's small.
Yeah.
Okay, that's pretty obvious. Okay, tell the students to pick out the one that glows, and oh, Helen's got a nice yellow glowing one. What is my color? Okay. And Katie's got one that glows. How about over here?
Yeah, that's just got a little piece in it.
Wiggle? It's hard to do.
Can you get over there?
Yeah,
Here we go. You got one that glows? You might have to turn it.
Yeah.
Rico's got some that you may have to turn it and find the vein of glowing material in the rock. Shamila's got one that's very, very obviously glowing. Okay? Everybody got the idea about the fluorescent rocks at this point? This is this one back here. Okay? The entire rock, Mark, at this point, if you turn the lights back on, the entire lot of lights may glow, a rock may glow, or just part of it may glow.
Okay.
Okay, so the first thing we've done is identified a fluorescent rock, and that can be put in the slot that says, obviously, fluorescent rock. Okay? Next thing we're going to do is there is a little, what's known as a streak plate. It's a little streak plate. Geologists use these to identify minerals. Student number 1, please pass this streak plate to student number 1. And student number 1, please look, get up, and go around to the other 4 students at the table and find the largest of those small green malachite pieces. Okay? I know they're all small, but anybody got at the table have a larger one? Okay?
Yeah, they're all about the same.
They're all tiny. I know there was a problem.
Yeah, if they would have been, they make a piece of dirt.
We're looking for all 6 samples now, but we're looking at the small green one.
Oh, you need to streak it, you're gonna need to streak it.
Yes. And what we're going to do is student number 1, once the largest of the small green rocks is determined at the table, take it, student number 1, that largest one, and take your other 5 rock samples and scratch that plate, that streak plate with them. You just scratch the surface of the plate with the rock samples and see if any of them leaves a streak behind.
You wanna go to my chair so I can see this?
And literally, I'm just gonna scratch it.
Yes, here we go.
Literally going to scratch the surface of the streak plate.
Broke that rock apart. That one's stretched.
Scratch it pretty good because the little green one does in fact give a green scratch, but it's very faint. It's hard to see. And it, of course, is the smallest one.
I think the pyrite scratched, and then the hematite scratched, and then the
Oh, Mike's
malachite
got
is
it.
a little green. Did you
Mike's
see all
got
that?
Okay, so student number
That's
one,
probably the,
please show the other four students at the table. Student number one, please show the other four students at the table the rocks that cause the streaks. Okay?
Pyrite and hematite.
Pyrite and hematite. Pyrite is the one that looks like fool's gold. Mike's got it. Mike's doing it.
Yeah.
And the hematite also gave a brown streak, right?
Yeah.
And the malachite, the green one, should have given a faint green streak. The others did not give a streak. So now we can classify those three minerals, the hematite, the malachite, and the pyrite, and put them in the appropriate slots in the rock collection.
Yeah. Pyrite's the sparkly one.
Which one is the hematite? The dark one?
Excuse me?
Hematite is the black one?
No, the hematite is what's brownish, dark brown.
That was your fluorescent one, which it wasn't.
Hematite, pyrite,
Okay, that's what I thought.
Okay?
malachite.
Hematite is dark brown. The pyrite looks like fool's gold, little speckles of,
That's not right.
was it iron sulfide? I think it's that.
Sulfide.
And then, malachite is the green one. Okay, at this point, each student should have 3 unidentified rock samples.
Yeah.
All right? You have in front of you a cup marked 2 and a spoon. Please take your 3 unidentified rock samples, put them on the spoon, and lower them into the water
All together?
all together. And let's see what happens.
But we need to continue on.
Put them in the water.
Yeah, just
Dump,
put it in the
just
water. 'Cause
dump them in the water.
Pull your spoon up.
Dump them in the water and let's see what happens. Pour them all. I'll put them all right in the water.
Yeah.
I put the pumice in.
Well, the pumice is supposed to go in there because it's supposed to float.
That's right.
I know, I put
That's
it.
what
For you guys, what we're doing is we're putting the marble, the limestone, and the pumice samples into the water,
Okay.
and sure enough, the pumice should float. Yeah. Its bulk specific gravity is less than 1. How's that? Okay? So now take the pumice and dry it off with your paper towel. You know which one it is now. And put it in the appropriate slot in your rock collection. Yeah, pumice does have a tendency to look like pumice, yes. Okay. We have 2 samples left. If you would fish them out of the water with your spoon, put them on the paper towel and dry them off. Student number 1,
All right, Joyce,
there is a vial,
is this number 1 still or number 2?
still student number 1, there is a vial, just a plain vial with a liquid in it at the center of the table, and there should be on each person's plate a
Yeah.
pipette.
This is the ashes for the limestone, right?
She's jumping the gun, but yes. Student number 1, take
Could be her.
Okay, take the bottle, remove the parafilm, open the bottle. Now this is 0.3 molar HCl, okay? It's not the strongest, but it's not the weakest either. 3 molar HCl. Fill the pipette and demonstrate to the students, to the kids, how to fill these pipettes.
I usually have them do it in the water before we get to this.
Well, if you do,
Practice
you might
filling
dilute
and
the acid
stirring.
a little bit. Have them do it right in the acid,
Okay.
okay? And what we're going to do is, I'm not even gonna bother with the parafilm. I'm going to take the pipette, put it into the acid, squeeze the bulb, and of course, when I do that, acid goes all over the place. Didn't need to put it in so far. And now I'm going to ask student number 1 to put a drop or 2 of the acid on each of the 2 remaining rock samples and see what happens. And student number 1, pass the vial of HCl around to the other students, please, so they can all test the HCl.
Do we want to issue any additional warnings about the acid?
You're doing it for everybody.
There are several warnings in the script.
Okay,
Everybody should be wearing their goggles at this point,
and gloves?
and gloves. That's why you have the gloves on. And student number 1, there is a magnifying glass in the middle of the table. Please open it up and examine the 2 samples with the magnifying glass. You should see CO2 bubbles forming on both of the samples. They're both calcium carbonate. Remember when we talked about the rock cycle, we said that the sedimentary rocks form from the igneous rocks by erosion, and then the metamorphic rocks form by compaction from sedimentary rocks. So chemically they're identical. They just differ in morphology, the last 2 samples. So take the magnifying glass and examine it. Do you see bubbles forming?
You know what, she suggested here, her student, that maybe because they were previously wet, they're not.
I wondered about that.
Yeah.
Well, maybe you dry them. If you dry them completely, does that work?
I don't know, I'm ready for the magnifying glasses.
I don't know. Well, my husband's a geologist, and when he does his presentations, he's going crazy.
Well, yeah, but we're dealing, I would too, but we're dealing.
We would take it and just do it ourselves around to the kids. That would be
There's a thought, yeah.
the only thing you could do, because I don't think they're gonna dry them enough to see this.
Well, what we could do, if they're not going to dry enough, what we could do is reverse the order of these.
Yeah.
We could do the acid test first,
Yeah. it won't
and
hurt
then
pumice
check
for
for the
acid.
pumice at the end.
Yeah, let's try it on a dry set. Here, you have a dry set?
Yeah, here we go.
Yeah. Put it on a paper towel.
This one, this.
Well, this big one, some people have that too.
Oh, maybe that is marble, yeah, you're right.
This is the limestone.
No, this is not it.
Yeah.
So what are we finding?
It's really small.
No bubbles?
There's,
Yeah.
on the dry, there's bubbles, they're just really small.
They're really small, yeah.
Really small.
Yeah. What we used to do is just have a more concentrated thing of acid, and he would go around and put the drop on for them, and they would look at it. Cause it'll bubble right up.
Yeah, it will definitely
Yeah.
bubble. Well, we'll have to tell them that, believe it or not, there are bubbles there, they're microscopic. Let's reverse the order. People watching the video, do not dump the 3 samples into the water first. Do the acid test first and switch these 2. And then, once you've done the acid test, put them all 3 into the water. That will identify the pumice. That leaves you with marble and limestone. And they should both have bubbled. I guess the pumice will bubble too. I guess it's limestone, or I guess it's calcium carbonate as well. And then at the end, you'll know which one's pumice. You can put the pumice one in there. And what you can do is look, lastly now, using that magnifying glass, look at the structure of the limestone and the marble. The limestone sample is grainy. Remember, it was formed, it's a sedimentary rock, and it was formed from sediments which were sand or mud and that sort of thing. So the limestone sample is grainy. The marble sample is more crystalline, it's a little shinier, and it's less grainy. Can everybody identify the limestone and differentiate between the limestone and the marble? Okay. All right. I think you've got the idea with experiment number 2. When it's complete, the students will have a rock collection, and they can take that rock collection home with them. Okay?
In terms of being crystalline, the marble also just, when you move it, has flashes.
Yes, it's more crystalline, it's shinier, it tends to be shiny. Okay?
Yeah.
The limestone is dull, it's grainy, and if you look at it under the magnifying glass, you can pretty much tell that. Okay, now, at this point, all the students except number 3 can remove their gloves. Student number 3, keep your gloves on.
Yeah, I keep my gloves on, I'm here.
Okay, Miss Arendt. No, I beg your pardon. We're going to go to experiment number 3. Katie, you'll do yours next. Experiment number 3 demonstrates how some less reactive metals like copper are replaced in compounds by more reactive compounds like aluminum. And what we're going to do is, at the center of each table, student number 3, you have a little vial, and we're going to need a little bit of water for this. We didn't get there's water left over from W1, you can use that. So take some of your water from number 1, student number 3, open this tube in the center of the table, and fill it with water up to about the 7 mil mark. Okay, I'm going to cheat and use a beaker. Okay, fill it up to about the 7 mil mark. Okay, recap it and dissolve
You know what, it almost would be just
the copper sulfate.
Yeah, a pipette would be better.
Yeah, you can use the pipette.
Yeah, that would be better.
I'm thinking if you're spilling these kids, you're gonna.
I have to admit
Oh, yeah.
one thing. When we made the partial kits, I'm not sure we adjusted the amount of copper sulfate. So when I divvied them up into these
So shake that.
3 tubes, as opposed to 5 tubes in full kits,
It
we
may
used
be
a
more
partial
concentrated.
kit. There's a little bit too much. So I guess we're going to get a supersaturated solution here. So I'm still not getting all my
Yeah.
copper to dissolve.
No,
So let's try a little bit more. I'm going to take it up to about 9.
it's not.
No, not at all. Yeah,
No.
it's-
So you said add more water.
Add a little more water. The idea is to get the copper sulfate in solution.
Oh, this is a lot of copper sulfate.
There's a suggestion here to dissolve it ahead of time.
Okay, that's a good
That would
possibility
be a
too.
good idea, then you could pull out the
Yeah.
undissolved.
If it's
Yeah.
if it's still undissolved, it probably won't matter. You've got the copper sulfate in solution.
Well,
And a saturated solution at that.
Yeah, it better be a saturated solution if it won't dissolve. Okay, so we have a saturated solution of copper sulfate. While student number 3 is shaking it, student number 4, get the small piece of aluminum foil and tear it into several, like 5, 6, 7, 8 small strips.
wow.
Okay? And sit them next to student number 3, who, wearing their gloves, is shortly going to drop these pieces of aluminum foil into the 10 mil vial. I've got like 6 pieces of aluminum foil here. So the active metals here are copper in the copper sulfate solution, and aluminum